Let's take a look at the following. In this particular video, we're going to evaluate a log. And the way we need to think about the following is that if we start with an equation in what we call logarithmic form, let's remember, that it has a corresponding exponential form that goes with it, so that we can remember that a log is nothing else than an exponent. So if you take a look right here, you notice that your base is a base b, and you notice here showing up as a base. Now we do notice that y in the exponential form plays a role of an exponent on that base. So y is the exponent. I must raise the base b2 in order to get x, this quantity x. So let me say that again. Y is the exponent that I must place on the base b in order to have x. Now let's see where those are located in the logarithmic expression over here. If you have y is log base b of x, notice that the log quantity, which shows up on the right hand side, is equal to y. And remember, y was the exponent. So we notice the following, that our log right here is equal to y, and y is the exponent. So that helps us conclude that a log is an exponent. So let's remember that. So when we write log base b of x, we're talking about it being equal to y being an exponent. So a log is an exponent. That's a key thing we need to remember. So a log is an exponent. Now it's a special exponent. Let's see how we can get a clue about which value it should have. If you were to take the base b, which is hanging from the letter g, and raise that base to an exponent, you will get that it's equal to something. Now, where do the pieces go? Y being the exponent, because it's a log, y will go on the base, and that base raised to the power y will give me x. So keep in mind, when we say y is log base b of x, or log base b of x is y, whichever way you want to say that, keep in mind that the clue we have about the exponent y is such that if you take that exponent y and you place it on the base b, then what do you get? You'll get x, which is a quantity inside the log. So let's take a look. Log base b of x is equal to y. What does that mean to us? It means that if we take the base and you raise it to the exponent y, so b raised to the exponent y, that's equal to the quantity x, which is inside the log. So keep that in mind. I'll say it one last time over here, then we'll practice. Log base b of x, what is that? It is an exponent that I must place on the base b in order to get the quantity inside the log. So the base b raised to my mystery exponent should give me the quantity x, which is in the log. So let's see how they use that information in order to answer something. If you take a look, they are telling us, oh, let's remember right here, let's remember that logarithms are exponents that make it possible to evaluate Oh, sorry, let me say that again. Remembering that logarithms are exponents makes it possible to evaluate some logarithms by inspection. So that's an important thing. Let's remember that logarithms are exponents. And that should help us when we're trying to find the value of a log without doing too much work. So let me go ahead and show you what they're thinking about. They're telling you here that if you want to find, again, log base b of x, which is what they're saying here, it is an exponent, because a log is an exponent, that I must raise the base 2 in order to get x. So b raised to that mystery exponent, which is the value of that log we're looking for, is equal to the quantity inside the log. So they're saying, for example, let's try to find log base 2 of 32. We don't know what it is. So let's write what we're being asked to find, log base 2 of 32. Let's identify the base, which is 2. And we don't know what it's worth, but we know what we're looking for, being that it's equal to a log. We know what we're looking for is an exponent. So log base 2 of 32 is an exponent. Now, what kind of clue do I have about this exponent, which is my answer, and that I'm looking for? If I take the base 2 and I raise it to that exponent, so let me write it so you can see what I'm doing. If I take 2 raised to that exponent, what do I expect to get? I expect to get the quantity inside the log, which is 32. So I'm really asking you, what is the exponent here that is the answer, such that if I raise 2 to that exponent, I'll get 32. So that's what I'm asking. So what you can do is the following. You can say, okay, which power of 2 gives you 32? So let's see. 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8, 2 to the fourth power is 16, and 2 to the fifth power is 32. So I need 5 2's in order to say get to 32. So 2 raised to the power 5 will give me a 32. You could think about it by slowly building, your 2's to get 32. So 5 is that exponent I was looking for in order to raise 2 to that power and get 32, the quantity inside the log. So I did find that exponent. That exponent is 5. So log base 2 of 32 is 5. That's my answer. So I could do it that way. If you didn't like the way I built it up, I built up to 32, you could do this. You could take 32 and say it's 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. So you could notice that 32 is a bunch of 2's timing each other. So we have 32 is 2 times 2 times 2 times 2 times 2. A quicker way to say that is it's 2 raised to the power 5. So you could have done it this way by identifying that 5 was the power, the exponent I needed to raise the base 2 in order to get 32. And you could have identified that that exponent you were looking for had to be 5. Okay. I'll show you one last thing about this, and then we'll do some other examples in another video to follow up. When you are at this stage trying to get your clue about what is log base 2 of 32, and you don't know what it is, but you do know it's an exponent, and you know it is an exponent such that if you raise 2 to that power, you get 32. You could do this. You could say, okay, 2 to my mystery exponent is equal to 32. Now let's say you broke down 32 and you know 32 can be rewritten as 2 to the fifths according to this prime factorization which I have right here. So then you have on the other side, you have 2 raised to that mystery exponent you're looking for is equal to 32, but 32 I wrote it as also the same base 2 raised now to the power 5. So that's the same base 2. Now there's a property in math that says when you have the same base over here on both sides raised to some exponents, and it means the exponent that I have on the left has to be a match to the exponent on the right. So 2 to the mystery exponent power, if it's equal to 2 to the fifth, then it means that the two exponents are matching just because we had the same base here and there. So that's telling me that the exponent that I'm looking for, that mystery exponent, had to be 5. And keep in mind that we knew the answer to my question, what they were asking, would be that exponent. So you come back and you say, okay, I get it. You're asking me what is log base 2 of 32. I know it is an exponent, but I just found that exponent should be 5. So I know my answer. So I can say, okay, I got it. The answer is 5. And I'm done. So keep in mind that we did that because 2 raised to an exponent, if it's equal to 2 to the fifth, then because the bases are the same, then the exponents should be matching as well. And that's a property which I mentioned right here. Let me show you. It's right here. If you have a base b raised to the power m equal to the same base b raised to a power n, then that means that because the bases are the same, they are both base b, then the exponents should be a match as well. And that happens because the function is 1 to 1. The exponential function with base b is what we call 1 to 1. So that's exactly what I used when I had 2 raised to that exponent is equal to the same base 2 raised to that power 5. Then because the bases are the same, then those exponents had to be a match. So my mystery exponent had to be 5. Think about it.